Hello learners, welcome to this program Education Online. I am teacher Akena Patrick Omoy, a teacher of physics. So today we are going to look at the determination of focal length of convex lens. So dear learners, before we go and determine the focal length of convex lens, we have to first know what focal length is. We say focal length refers to the distance between the optical center and the principal focus. The principal focus of the lens. If this is a convex lens, then a line through the optical center and the principal focus is called the principal axis. This is the principal axis. Then we have a point. This is the optical center, O. Then one point on one side of the lens, this is called the principal focus F, and on another side we also have another principal focus. So a convex lens has two principal foci, that is on both sides of the lens. Then the distance between the principal focus and the optical center is called the focal length. We denote it with the small letter F. Then also on the other side, the distance again between the principal focus and the optical center is also called F, which is the focal length of the lens. So dear learners, we are going to look at how we can determine the focal length of the lens. So we have methods that we can use in the determination of the focal length of a lens. So these methods, one is called the plane mirror method. Plane mirror method. This plane mirror method can also be called non-parallax method. The plane mirror method or non-parallax method. So this is one of the methods that we shall use in the determination of focal length of a lens. The word non-parallax means the image and the object are going to be in coincidence. They are going to coincide, means they will be formed at the same position. But what we are going to use is the plane mirror. So now in using this method, we have apparatus that we have to use. Apparatus. These are the materials that are needed when we want to determine the focal length of a lens, that is using the mirror method or a method called the non-parallax method. So these apparatus are, one is the lens itself. The lens. And which type of lens are we going to use? We are going to use the convex lens. That is the first material that we have to, that should be in place so that we can determine the focal length of the lens. Then the next thing that we need to have is the plane mirror. Plane mirror. Then we need to have a pin or optical pin. Then the next apparatus that we need to have is the stand. So dear learners, in using this method, this apparatus must be in place. One is the convex lens. Then two, we need to have the plane mirror. 3, we need to have the optical pin, and we need to have also the stand. So now these are the procedures that we need to follow. Procedures that we need to follow in determination of the focal length of a lens using the mirror method or the non-parallax method. So the first procedure is, what we are going to do is, we shall place the plane mirror on a table and place the lens on it. So this is the first procedure that we have to do. 1, we are going to place the plane mirror on a table and we place the lens on it, meaning we place the lens on the mirror. Then 2, the second step that we are supposed to follow in the determination of the focal length, still using this non-parallax method, we are going to clamp the optical pin, clamp the optical pin horizontally on the stand. To clamp it means we are supposed to fix the optical pin on the stand, or we make the stand to hold this optical pin, but we put it horizontally, that is in this form. When you put it like this, this is horizontally. So this is how we are going to clamp the optical pin. Then the third step that we have to do is, we are going to adjust the position of the pin. Adjust the position of the pin until the pin coincides with its image while viewing from above. So dear learners, this is the third step. 1, you are going to adjust the position of the pin until the pin coincides with its image while you are viewing from above. So dear learners, this is how we are going to illustrate these procedures. So we are going to have, this is a plane mirror. This plane mirror is placed on a table. This plane mirror is placed on a table. So we call this mirror. Then that is the first step, which says place the plane mirror on a table and place the lens on it. So we are going to place our lens on top of this plane mirror. So this is how we are going to place the lens. This is still in the first procedure, which says place the plane mirror on the table and place the lens on it. So we have also placed this lens. This is the lens. So we have placed this lens on the plane mirror. Then the second procedure says clamp the optical pin horizontally on the stand, which means we are going to fix the optical pin on the stand. So if we put our stand at this point, if this is our stand, this is the stand. So we are going to clamp our optical pin on this on this stand. So this is how we're going, this is where we are putting our optical pin. So this is our optical pin. We have clamped it on this stand, or we have fixed it on this stand. So that is the second procedure, which says clamp the optical pin horizontally on the stand. We can see this pin is lying horizontally. Then this pin, we are going to adjust it, adjust the position of the pin until the pin coincides with its image. So now we have the principal axis of this lens, that is a line that passes through the optical center and the principal focus. So this is the principal axis of this lens. So if this is the pin, so we are going to adjust the position of this pin, meaning we shall be moving it up and down. We move it up, then we bring it down as we are viewing from above. This is the observer. So now as we move this pin up and down, we shall be viewing it from this direction. So we shall reach a point that we shall see the image is going to be formed on this side, and this is how the image will be. The image will be formed on this side, but the image will coincide with the object, meaning they will be formed at the same position. But we shall find that rays of light from this pin will fall on this lens. So if a ray falls from here to this point on the lens, so this ray falls in that direction. Then we have also a ray from this part of the pin will also fall on this point of the lens. Then this ray will come to the plane mirror. So we shall find that this ray, when it touches a portion of the lens, it will be refracted and it will hit the mirror at right angle. So when it hits it at right angle, it is going to be reflected back through the original path. So if this ray in this direction hits the mirror at this point, so it will be reflected back along its path. So the direction will also change on the same path. Then the same also in this direction. So that is after adjusting the position of the lens, that is by moving it up and down while observing from a point above. So now in this point, we are going to say this is the object O, then this is the image I, and the object is the pin. So dear learners, after arranging all this, what we are going to do, we are going to measure the distance between the lens and the object, that is at the position where the object coincides with its image. So if we measure this distance from this point up to the object, so this distance is what is called the focal length of the lens. That is the distance between the optical center, because the optical center is at this point, and the principal focus. So which means the point where the object will coincide with the image becomes the principal focus, and the distance between the optical center and the principal focus is the focal length of the lens. So dear learners, you are going to conclude. You are going to conclude. And in the conclusion, so we're going to have conclusion. So we're going to say the distance between the lens and the object, and the object is measured, and this gives the focal length, of the lens. Dear learners, this is one of the methods that we shall use in the determination of the focal length of a lens. So you need to follow these procedures. One, you are going to place the plane mirror on the table. Then after placing the plane mirror, you place the lens on top of the plane mirror. Then you are going to clamp a pin or an optical pin on this stand. So when you clamp the optical pin, you are going to move the pin up and down. Meanwhile, rays from the pin will be focused on the lens. So when it touches the lens, it is going to be refracted to the mirror. But it hits the mirror at a right angle, which means the ray will be reflected back in its original path. Then the point where the object will coincide with the image is marked. Then the distance between the lens and the object will be measured, and that gives the focal length of the lens. So the word non-parallax means the image and the object and the image will be in coincidence, means they will be formed at the same position, they coincide. Then dear learners, let's also look at the second method that we can use in the determination of focal length of a lens. I said there are so many methods that can be used. The first method is called the mirror method or the non-parallax method. Then the second method is called the rough method. The rough method. This rough method can also be called object distance method. The rough method or the object distance method. So this is the second method that we are going to use in the determination of the focal length of a lens, and we are dealing with convex lens. So the apparatus that we need to have, apparatus or the materials that are needed for us to determine the focal length of a lens using these methods are: one, we need to have the convex lens. That is the first apparatus that is needed. Then two, we need to have the lens holder. Lens holder. Need to have the lens holder. Then we need to have a screen. So these are the important three apparatus that we need to have when we are going to determine the focal length of a convex lens, that is using the rough method or the object distance method. Dear learners, we have procedures that we have to follow. Procedures that we need to follow when determining the focal length of a lens or of a convex lens using the rough method or the object distance method. So the first procedure is we are going to place the lens. Place the lens on the lens holder. On the lens holder in front of the screen. Of the screen. Dear learners, this is the first procedure that you need to follow. 1. You place the lens on the lens holder. You place the lens on the lens holder. On the lens holder. Place the lens on the lens holder in front of the screen. So this is the first procedure that you need to follow. Then what about the second procedure? What do you do after placing the lens on the lens holder in front of the screen? What next do you have to do? And that one is the second procedure. After placing the lens on the lens holder and you place it in front of the screen. So the second procedure, that is procedure number 2, is you're going to adjust the position of the screen until a sharp image is formed on the screen. Dear learners, this is the second procedure that we are going to follow. We are going to adjust the position of the screen until a sharp image is formed on the screen. Then 3, we are going to measure the distance between the lens and the screen. We are going to measure the distance between the lens and the screen. Dear learners, these are the 3 important procedures that we have to follow. 1, we are going to place the lens on the lens holder in front of the screen. Then 2, we are going to adjust the position of the screen until a sharp image is formed on the screen. And lastly, we are going to measure the distance between the screen and the lens. So dear learners, this is how the arrangement looks like. So 1, we are going to place the lens on the lens holder. So this is our lens. We are using a convex lens. So this is our convex lens. So this lens, we are going to place it on a lens holder. So this is the lens holder. So this is our lens. Then this is the lens holder. This is the first step. We have already placed the lens on the lens holder, but this lens holder should be in front of the screen. So we are going to place our screen on one side. So if this is our screen, this is the screen. At least the screen should be supported by some stand so that it does not fall. So dear learners, this is the first procedure. We have placed the lens on the lens holder and it is in front of the screen. So now the second step is to adjust the position of the screen until a sharp image is formed on the screen. Now, as the name of the method says, the object distance method, which means we have some object at a certain distance which is far away from this lens, but the rays from the object are focus on the lens. So now if we have a distant object, that is an object very far away from the lens. So this is a ray from a distant object. That is an object which is far away. Also, if we have another ray, because the ray cannot be only one, there can be rays, many rays that will be falling on this lens. If we also have another ray that is still from a distant object. So these two, we call them rays. Rays from distant object. Distant object. So when these rays fall on the lens, this lens is going to refract the rays. When it refracts, the rays are going to be formed at a certain point on the screen. So this ray will be refracted to a certain point in this direction, because we said rays which are always parallel and close to the principal axis will always converge to a certain point, that is after refraction from a convex lens. Also, this ray will also be refracted to a certain point on the screen. To a certain point on the screen. That is when it touches the lens, it is going to also be refracted through the principal focus. So now, these rays will only be formed at this point after we have adjusted the position of the screen, meaning we move it outward and inward. So we move it until these rays meet at a certain point on the screen, meaning a sharp image will be formed on the screen. So now when these two rays meet at a certain point on the screen, so we are going to measure the distance between the lens and the screen. Dear learners, this is our lens and the center of the lens is at this point. Then this is the screen. So now we are going to measure this distance. The distance between the lens and the screen. So now in our conclusion, we shall say the distance between the lens and the screen is the focal length of the lens. So when we measure the distance between the lens and the screen, that becomes the focal length of the lens. So dear learners, these are two important procedures, these are two important methods that we use in the determination of focal length of a lens. So we say this is a rough method. A rough method because the distance of the object is not known. Then also the position where it is formed is got after moving the object, the screen outward and inward. So we move it until a sharp image is formed. So we call this method a rough method because there is no measurement to scale here. We don't know the distance of the object. So dear learners, these are two important methods that we have to know. You can be asked in an examination, describe an experiment how you can determine the focal length of a lens using the rough method or by the rough method. So when you are asked, these are the things that you have to follow. One, you need to write the apparatus. That is the materials needed in the determination. You will write the convex lens, the lens holder, the screen. Then you also write the procedures. It is not a must that your procedures should be 3. You can divide them, like here we have placed the lens on the lens holder. You can have this as a first procedure. Then the second procedure can be, then you place the lens holder in front of the screen. So it is not a must that your procedures should be 3. You can have as many as you can, but it should be within the content on how you can get the focal length. So dear learners, this is how a question will be asked in examination or any other test or exercise. The question can be in this form. Question: describe an experiment. Describe an experiment. Describe an experiment to determine describe an experiment to determine the focal length. The focal length of a convex lens. By non-parallax method, or in bracket plane mirror method. So dear learners, this is how a question can be set. Describe an experiment to determine the focal length of a convex lens by non-parallax method. Or if they don't use the word non-parallax method, they can say by a plane mirror method. So what you have to do in this case, you are going to write the apparatus that are needed. After listing down the apparatus, you go to the procedures that you need to follow. Then after writing down the procedures, you can illustrate, you can draw. Then after the illustration, you conclude. Or sometimes the question may be asked and it will not be specified. The method that you are supposed to use will not be specified, which means you are free. You can either use the mirror method or the rough method. So it is you to decide. So dear learners, I hope up to this point we have come to the end of our today's lesson. I hope you enjoyed. I am teacher Kenna Patrick Kumon. Bye bye.